Hey everyone, today we're going to be finding the area of the unit circle with calculus, and I am done recording this video. I've recorded this video like 9 different times. Let's just get this done. So of course we know the equation for the unit circle. It's just x squared plus y, that's a y squared, equals 1. With this we can rearrange it to get y equals the square root of 1 minus x squared, in which we are going to take the integral. We're going to take this integral from -1 to 1, and of course it's going to be the square root of 1 minus x squared. Now, usually you'd multiply by 2. Turns out every time I multiply by 2 I'm wrong, so we're not going to be multiplying by 2. From here we're going to take square root of 1 minus x squared. We can make a substitution. In this case, it's actually the square root of a squared minus x squared. So going to be equal to cosine of theta, but of course a squared in this case is just 1. Next, we're going to have x is equal to a sine theta. Once again, a is 1, so it's going to be sine. Oh, let me erase that. This is going to be sine theta. And now dx is going to be equal to cosine theta d theta. This is all fine and dandy. We have to change our bounds though, so we're going to substitute in -1 and 1 for x here. That means sine of theta is going to be negative pi over 2 and pi over 2. So we're going to have our new integral from negative pi over 2 to just pi over 2. And this is going to be, since dx is cosine theta d theta, we have two cosines multiplying, so it's going to be cosine squared theta and then d theta. Now we're going to do more torturous substitutions because trig is so much fun. We are going to be substituting in a double angle identity and the only good trig identity. So we'll have cosine of 2 theta is equal to cosine squared theta minus sine squared theta. And then we're going to have, of course, the good old classic cosine squared theta plus sine squared theta is equal to 1. From here, what we're going to do is rearrange our second identity to solve for sine squared theta. That gets us 1 minus 1 minus cosine squared theta equals sine squared theta, in which we can substitute into our top identity. Simplifying a little bit of algebra out, we get cosine of 2 theta is equal to 2 cosine squared theta, and then it should be minus 1. Now we can solve this for cosine squared theta by adding 1 and dividing by 2. Ultimately, I'm going to write cosine squared theta on this side. So giving us cosine squared theta equal to 1 plus cosine of 2 theta, and this is all over 2. Now we have something we can substitute back into our original integral, in which I will write over here. So we still keep the same bounds, at least for now. So from negative pi over 2 to pi over 2, and this is going to be 1 plus cosine of 2 theta all over 2 d theta. Now we're going to do one last final substitution. I'm going to at first move the unit circle around. Unit circle, come here. We're going to throw your, yeah, we won't need you anymore anyway. We all know what the unit circle is. So we're going to let u, yes u, equal to theta. That makes du equal to 2 d theta, and of course we want to solve for d theta, so we'll divide by 2 on both sides. We get du over 2 equals d theta. Now I'm going to move my board over. I'm going to well, I don't want to move that. Now we're going to move over here. With our substitution in place, we're going to do a few things. First, we have to change our bounds once more. In this case, we're solving for u, so we're going to plug in negative pi over 2 and pi over 2 in for theta. That changes our bounds to just negative pi and pi. So we have negative pi, that's a terrible looking pi, but whatever, and pi, and then we'll have 1 plus cosine of just u now, 1 plus cosine of u, and it's going to be over 4 because we have to divide by 2 on both sides to isolate our d theta, so we're going to multiply our denominators. 1 plus cosine of u over 4, and we're in the u world now. Now we can finally integrate this, do some actual calculus, not the mind-numbing algebra. So we're going to split this fraction up. We have 1 over 4, and we'll have cosine of u over 4. 1 over 4 integrates into u over 4, and we'll have cosine of u over 4 integrating into sine of u over 4. But we are not done yet. I'm going to write this down here now. Because u is equal to 2 theta, we're going to resubstitute in our 2 theta. What this gets us is 2 theta over 4, which simplifies into theta over 2. And this is going to be adding sine of 2 theta, and this will still be over 4. And we're going to evaluate this at negative pi and pi. So now, we're going to start with our top bound. We'll have pi over 2 if we plug in pi for our thetas. So we'll have pi over 2. However, sine of 2 pi is 0, so we don't have to worry about that. We'll substitute in negative pi now. We'll have negative pi over 2. And once again, sine of negative 2 pi is also 0, much like sine of 2 pi. So we don't have to worry about that. So we're going to be subtracting a negative pi over 2, which of course gets us 2 pi over 2, or just pi, which is in fact the area of the unit circle via the actual formula pi r squared, because of course r of the unit circle is just 1, so 1 times pi is pi, so we get our answer. Usually you would have to multiply the integral by 2. However, every time I did that I was wrong, and I wanted to blow my eyeballs out of my skull, so we are not multiplying by 2. I'm not sure why we're not multiplying by 2. Could be something I'm doing wrong, could be something with the bounds and how from negative pi to pi, it's like, I don't know, you gotta go two pi's to get there, so it's like the full circumference of the circle, and therefore we don't have to multiply by 2. Whatever the case may be, from what I've done, it is not necessary to multiply by 2. Your results may vary if you're smarter than me, so yeah. Thank you for watching.